Oh, hi. Okay. We're going to do section 4.2 of Intermediate Algebra by Martin Gay, 4th edition. Section 2 is about systems of equations, where you have 3 equations and 3 unknowns. It's like 2 equations with 2 unknowns, only there's more work. It's harder, but the ideas are the same. So let's start off. X plus y minus z is equal to -1. Negative 4x minus y plus 2z is equal to -7. 2x minus 2y minus 5z is equal to +7. Okay, now the idea is to start off with 3 equations with 3 unknowns, but then to go to the next step is to reduce these to 2 equations in 2 unknowns. And then if you have it from 2 equations and 2 unknowns, that's the same as what we've already done. We did that last time. So it's just a 2-step process. So there's probably more than one way to do this, but as always, as long as you don't make a math error while you're working on it, you can always still get the right answer, even if you don't do it the shortest way. So the key is just to try to keep what you're doing accurate. Okay, now let's try this. We can take the first 2 equations and we can eliminate the y variable. Okay, that'll give us an equation that has the y variable eliminated. Then we could take, let's say, the first equation and the third equation and try to eliminate the y variable. That'll give us another equation with the y variable eliminated. Then we'll have 2 equations with 2 unknowns. So that's going to be the basic strategy. Okay, the way we're going to, and that's what we'll call step A. This will be a 2-step process, step A and step B. So to get rid of the y variable by using the first 2 equations, we're just going to add them because it's going to cancel, right? So we're going to get negative 3y, 3x, negative 3x, plus z is equal to negative 8. Okay? Then we're going to take the first equation and the third equation, and we're going to try to cancel y. Now, we can't just add them, but if we multiply the first equation by 2, then we could add them. Okay? Now to save space, I'm going to change the first equation now that I'm done with it. Let's put it this way. We're done with that second equation. We've already used it to get this, and we're just going to keep moving forward. When I multiply the first equation by 2, this just save us some space. Because now we're going to use that to eliminate the y between the first and the third equation, so we can get a second equation with only x and z. And we're just going to do exactly what we did. We're going to add them. 4x, the y's cancel, minus 7z. Okay, now we have to look, this is a minus 2. We're just adding these together, and this is equal to 5. So now we have 2 equations with 2 unknowns. This is exactly where we were last lesson. We were solving those. Now, you might just say we could stop here because we already did that, but we're going to continue on to eliminate variables. Let's say we're going to, in this case, I'm going to try to eliminate the z, because it's a single z here. So if we multiply the first equation by 7 and add them, it's going to eliminate the z, right? certainly going to eliminate the z. So let's do that. First equation multiplied by 7. I won't X this one out because I have enough room here. I'll go minus 21 plus 7z minus 56. 56, 7 times 8. 6 times 8 is 48. 7 times 8 is 56. Yeah, gotta be an even number. Okay, that's right. Okay, now we're gonna add these two, because this is really the same equation as that. It's a different form. It's just multiplied by 7. We're going to add these two, and we're going to get 2x is equal to negative 51, or x is equal to negative 51 divided by 2. I'm sorry. Yeah, that's right. No, I'm sorry. I got sloppy here. This is a 21x. I thought it was 2x. That's 21x plus 7z. Okay, so yeah, my mistake. I'm going to add 4x to negative 21x. That's going to be negative 17x. And one of the giveaways was I came up with a number that was a very unusual number. That's sometimes a sign that you made a mistake. This is minus 17x is equal to negative 51. And the key here is 51 is equal to 3 times 17. So this tells us that x is equal to 3. That's the start of our problem. Once we have that information, we can go back and plug that in, let's say, to this one to get z, right? So 4 times 3 is 12. We can take the 12, move it to the other side, where it's going to become negative 7. Negative 7z is equal to negative 7. So z is actually plus 1. I did all that in my head. I could have written it out, but I'm running out a little bit on board space. And now we can just, to make sure I'm not making a mistake though, I'm gonna check this by putting it back in. So z is 1. That means this is negative 7. X is 3. That means this is 12. 12 minus 7 equals 5. So this is correct. Now we can go up to the next stage and try to find what is the y. Okay, and here we can use any one of these, but it's probably going to be easiest to use the one that I had x'd out. Maybe I shouldn't have x'd it out, because I can isolate the y very easily on that. I put the y to the other side. That y is going to be 2z minus 4x plus 7. I have room here, so let me just do that. Y is equal to 4x plus 2z minus 7. Okay, now we're going to plug all these in. 4 times 3, that's 12. Plus 2, that's 14. Minus 7, 14 minus 7 is 7. So y is 7. We could check that, but I'm confident that that's going to be correct. Now you can see, oh, this is a lot of work. And there's a lot of chances to make mistakes. So at the very end, it's very, very useful to plug it back in again. So let's take that and put it into here again. That's going to be negative 12 minus 7. Okay. Yeah, negative 12 minus 7, that'll be minus 19, actually. And then minus 19, oh, hold on. Let's see if I got that right. Did I get that right? Let's see. I used that equation to solve it. Let me just double check it. Y, no, it is wrong, because I moved the y to the other side. So that should have been negative 4x. Okay, and then it would have been plus 7. Okay, I was isolating y, I moved it to the other side, I moved the 7 over. What I'm left with is negative 4x, positive 7, and plus 2z. Okay, so by checking it out at the end, I did find a mistake, even though I said I was confident. So that shows you something right there. Okay, now we're going to go ahead and plug these in to get the value for y. That's negative 12 plus 2, that's negative 10, plus 7, negative 3. Now we can plug that in. We can plug it into any one of these, but let's just plug it into the second one, because that's what we're doing. Minus 12 minus a minus 3, that's the same as plus 3. So minus 12 plus 3 is negative 9. Negative 9 plus 2, because I'm putting z equals 1, is equal to negative 7. So that's a check. So this is confirmed. I double checked it. I double checked it just by checking it with one of the equations, but that's adequate. Okay, that's number 2. And that shows you how long these are going to take. But some of them will get easier. That one didn't seem to have any very many simplifications. Okay, this one is going to be 5x equals 5, 2x plus y is equal to 4, 3x plus y minus 4z is equal to negative 15. Okay, this is a so-called triangular set of equations because you can see they form a triangle. And when they're triangular, they usually are easier to solve. The idea on this is pretty obvious. We know x right from the very first equation, so there we go. X equals 1. Plug that into the second one. That's just 2 plus something equals 4. So y is equal to 2. And we plug that into the third one. That's just, it says 3 plus 2. Hold on. What did I do? That should have been a 4z. For some reason I wrote zz. Okay? So this is 3 plus 2. That's 5. 5 minus 4z is equal to negative 15. So let's just write that. 5 minus 4z is equal to negative 15. Bring the 5 to the other side. We have negative 4z is equal to negative 20. Or z is equal to 5. Okay, now that we have it, let's just plug it in here. It's just double checking. Negative 4 times 5, that's negative 20. That's 3 plus 2, that's 5. Minus 20 is negative 15, so that's correct. So that one was easier, admittedly much easier. Almost direct solution. Now let's go to number 6. 2x minus 3y plus z equals 5. X plus y plus z equals 0. And 4x plus 2y plus 4z is equal to 4. Okay, well, we need to eliminate. So just because there's a z and a z, let's use the strategy of eliminating the z. Because they have the same magnitude. The idea is that we can just subtract the equations and that will eliminate the z. So we'll take the first equation minus the second equation. 2x minus x is x. Negative 3y minus y is negative 4y. Z minus z is 0, and that's equal to 5. Okay. Now we want to take this third equation, and by either combining it with either the second or the first, whichever is easier, we need to cancel out the z. Okay, I'm going to say let's use the second one because the second one has a nice, very simple form. To cancel it out, the z, if we're using the second one and the first one, let's just multiply the second one by 4 all the way up through, for example. Okay, then we can take this one minus that one, and that's going to eliminate the z. And that's going to come out really nice. 4x minus 4x is 0. 2x minus 2y is 2y. 4z minus 4z is 0. And 0 minus 4 is negative 4. So immediately get y is equal to negative 2. Wow, very helpful. And we go into this one here. If y is negative 2, then negative 4 times negative 2 is 8. X plus 8 is equal to 5. X has to equal negative 3. Okay. Oh, did I say negative 3? I wrote positive 3. Let's just double check that. Negative 3 plus 8 equals 5. So that's correct. It is a negative 3. I'm having making a lot of simple mistakes, and I know that that's true. I do make simple mistakes when I'm doing a lot of math, and sometimes I have to go by twice through a problem. And very often I get in the habit of checking my answer at the end, almost always. Just because it's a homework assignment or a test, you actually don't get credit for getting the wrong answer. And then of course, at a job, you can't have the wrong answer, you have to check it. But you're using a computer if you're at a job doing it. This is to make you stronger, all-around thinker, especially when it comes to mathematical concepts. Okay, now let's go and find out what is the value of z. Okay, we can use any one of these. And I'm going to say, let's go back to this one here. That was a very simple one. Let's solve for z on this one. Z is just going to be the negative of x plus y. So here, z is going to be equal to 5. Because x plus y plus equals 0. So that's negative 3 plus negative 2 is negative 5. So z has to equal 5. Okay, so that satisfies that equation. So that's good enough for me. Okay, that's number 6. Let's go to number 8. 3x plus y minus 2z equals 2. Negative 6x minus 2y plus 4z is equal to negative 4. 9x plus 3y minus 6z is equal to 6. Okay, so which one can be easily canceled? Well, I don't really notice any of them where variables are the same. Yeah, I do see something going on here. And that is if we take the first equation, subtract the second equation, we get the third equation. That's a problem. In other words, here's the problem. I don't know if they talked about this here, but I was just thinking whether or not they were going to give us a trick question. Now, let's say this is equation 1, and this is equation 2, and this is equation 3. Well, let's take the first equation and subtract the second equation. Okay, you're going to get 9x plus 3y minus 6z is equal to 6. Well, that's just the third equation, and that's a dead giveaway that these three equations are not independent. One of these, that is the third one, is nothing more than the difference of the first two. It's not an independent equation. And this is what they call, I don't know why I noticed that, but I kind of saw the way these numbers were lining up, and I was suspicious that they were going to give us one that didn't have a solution. And this would be a system that's inconsistent. When you have there's really only two equations here. You can't get down to a single point. When you only have two equations, you get down to a line, basically. And I think they talk about this. Each of these in three-dimensional space, x, y, and z. So the idea is you imagine that you have a three-dimensional axis. Each of these is not the equation of a line, but it's the equation of a plane. And if you have two planes, it's like two sheets of paper. If they intersected, it would intersect in a line. And what's happening here is there's really only two, the first equation and the second equation form two planes, but the third equation forms the difference between them, but it's going to end up going through that exact same line. It'll be like a third plane which goes through the exact same line. It's not going to give you a single point because it's not independent, it's dependent. So it's what they call inconsistent. Okay? Three planes meet in a single point, that's called consistent. Three planes that meet in a line or don't meet at all, for example, if they're all parallel, that would be inconsistent. Those are forms of inconsistent. Oh, I'm sorry. Three planes intersect all at the points of a single line. This system has infinitely many solutions. So that system is called consistent. Okay, that's what I'm thinking this one is. So my mistake. It's not inconsistent. I just got the definitions here mixed up, but these definitions are not terribly important. It's just that there is no solution to this equation, no matter what you call it. You're not going to get a point x, y, and z, but you will get a certain line from this. And I don't think they're not asking you to do that, see, so get a line for it. So the answer on this is basically that there is no solution. These three planes are going to intersect a single line. They don't really talk too much about exactly how this is. If they're two lines that are parallel, yeah, now I'm not exactly sure if this is going to turn out to be consistent or inconsistent. I know that there's not going to be a solution, an XYZ solution, but exactly if you, this third equation is the difference of the first two, and I'm not 100% sure if that means that it's going to meet in that same line. Let's just see if we can, if there was a point on this line which satisfied the first equation and the second equation, call it x1, x1, y1, z1. It's a solution of the first equation, and it's a solution of the second equation. We know that the solution of two planes, two independent planes, will be a line. Now, the question is, will that be a solution to this third equation? So what happens is if you plug that point x1, y1, and z1 up here, that gives 2. Plug it in here, it's going to give -4. Then when you take the difference of those two, this 9 yeah, what do you think about that? 9. This 9x, if you plugged in x1, y1, now my little marker's not going anywhere. y1, 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 y1. This one point is a solution for all these. Now, to 3x1 minus -6x1 yeah, I think it would be a solution of that. Because these, the 9x1 and the y1 and the -2, are all going to add to 2. This 9x1 and the 3y1 are going to add to 6. So, but what you're going to have on this side, this expression is really going to be the difference of 2 and -4. That is going to equal 6. So after thinking about it a little bit more, I will go with my original idea, and that is that any point on the line that is an intersection between these two planes will also satisfy this equation. And that, according to their definitions, if all three planes intersect on a single line, the system has infinitely many solutions, and they call the system consistent. They call it consistent just because there is a solution, at least one solution. They only use the term inconsistent when there are no solutions whatsoever. Okay, so it's a very long break I just took there, but that's what happens when I do these on the fly. And that just give you an idea of some thinking about that. Okay, you probably in your own problems run up against that exact same issue, so you'll have to deal with it. Okay, now, number 10. 5y minus 7z. Oh, 7z. I hope this screen doesn't run over now. Okay, 2x plus y plus 4z is equal to 10. 2x plus 6y minus 3z is equal to 30. Okay, well, let's see. We already got rid of the x in the first one, so that's kind of a giveaway. It looks like a hint that if we use the second two equations to eliminate the x, that we could then combine that with the first equation. That's a little bit of a shortcut. So let's take this one minus that one. Okay, y minus 6y, that's minus 5y. 4z minus a negative 3z, that's 7z. 7z. And then 10 minus 30 is negative 20. Okay? Now, so that means these two, so we get negative 5y minus 7z is equal to 14. These are our two equations now. Now we've reduced it to two equations and two unknowns. And you can see right off the bat, this is a handy little set because if we can eliminate the 7z by adding. Okay, we add them, that gives negative 10y. These cancel. We get negative 20 minus 14. Plus 14. Okay, negative 6. Yeah, not subtracting here. Okay. Yeah, not subtracting. Okay, so y is equal to 3/5. Ratio of 6 to 10, which is a little inconvenient. Because normally they don't come out to fractions like that, and that's a sign that I made a mistake. So let me just check it again, that I wrote it down correctly. Okay, 5y minus 7z, 2x plus y plus 4z, 2x plus 6y minus 3z. If a problem is coming out overly messy, that's often a sign that you made a mistake. So I take this equation minus the second one, negative 5y, that's 7z minus 20. I'll go with that. Okay, then, oh, that's funny. All I wanted to do was copy down this first one. I didn't copy it right. Okay, so that's why things got screwed up. Why didn't you mention that? Okay, I was supposed to copy it like this, for heaven's sakes. Yeah, okay. I was confused because I was beginning to think that these actually were the exact same equation, but it turned out they're not. Okay. Now, if I add these two, it's going to actually eliminate the y and the z. Oh yeah, so that is a problem. These are going to be inconsistent. There's going to be no solution here. In other words, if you have 5y minus 7z equal to 14, then when you take the negative of that, there's no way you could possibly get negative 20. That's impossible. And that's reflective of the fact that when there's no way to eliminate these equations are in fact on the so-called YZ plane. They're parallel. These are parallel lines. They have the same slope. This one reads, if you took the negative of this one, for example, it'll read 5y minus 7z is equal to 20. And then this 20, one says 20, one says 14. Those are going to be different y-intercepts. The slopes will be the same because the coefficients before the y and the z are going to be equal. Okay, so this is a sign there is no solution. Can be no solution, so inconsistent. That's the term, and we can stop it right there. Okay? Very good. Kind of stumbled on that, but now let's go on to number 12. X minus 5y equals 0. X minus z equals 0. Negative x, okay, plus 5z 0. So this looks a little bit suspicious. Certainly looks suspicious. Let's see. Certainly one solution here is if x, y, and z are all equal to 0. It kind of looks like that's going to be the solution to this equation, but let's just go through our steps. We can take the first two and eliminate the x rather easily, so let's do that. Take the first minus the second, okay? First minus the second, we're going to get negative 5y plus z equals 0. Now let's take the sum of the second two, and that's going to give us, that's going to cancel. We're going to get 4z is equal to 0, and we add them. That's going to tell us that z is equal to 0. And then we plug that in here, and that'll tell us that y is equal to 0. And then we can plug them into any one of these other equations. Well, not any one of them, but we plug it into either, we need to get x, yeah, so we can, yeah, right. You can actually put it in any one of these, and we're going to get x equals 0. I could tell that ahead of time, because if you had three equations, they all equal to 0, 0, 0, I can see that all of these equal to 0 is going to be a solution. And it's quite likely that it will be the only solution, unless there are multiple solutions like parallel planes or what have you. That's why I went through all the steps, just to make sure. Okay, so they are throwing a few unusual and or very simple ones. That one turned out to be a very simple one. That's speeding up a little bit how we get through this. X plus 2y, this is number 14 now, equals 6. 7x plus 3y plus z is equal to negative 33, and x minus z is equal to 16. Okay, so now what can we eliminate? Well, getting rid of this z looks like a fantastic idea because there's no z there to begin with. So we've got the first equation, and then let's sum the second two equations. That's going to be 8x, plus 3y. That's going to cancel. And negative 33 and positive 16, that's going to be a negative 17. Okay, so negative, almost made a mistake. Do have to concentrate. Okay, so that plus, I'll just recopy the first equation. These are now our two equations, and we can get rid of these. The easiest way might be by multiplying the second one by 8, 8, 16, 48. Then subtracting the two equations, 3y minus 16 is going to be a minus 13y. That's going to be equal to minus 17 minus 48, which is going to be a negative 50. Wow, 65. Does look unusual, so let me double check it. X plus 2y, 7x plus 3y plus z, negative 33. X minus c is equal to 16. So I added these second two. That was 8x plus 3y plus negative 17. That's okay. 16 plus 16 is 32. So I have 17. Okay. Then take the first equation and multiply it by 8. 8 times 6 is 48. Okay. Then I subtracted them. 3 minus 16, that is a negative 13. And negative 17 minus 48, that is negative 65. Wow. Can't believe it. Y is equal to 65 over 13. It's very unusual. But that's what it's looking like. So unless I made a mistake, which I do not see it, then I'm going to go on to solve this. I'm going to plug that in here, solve for x. Solving the first equation for x is equal to negative 2y plus 6. So x is going to be negative, wow, 2 times 65, that's 130. Okay, now things are starting to help work out a little bit. Divided by 13. Plus 6, so that is negative 10 plus 6, so that is negative 4. And that's a sign that maybe things are okay. Okay? Okay, because then once I have x, it's easy to get z, because this is negative 4, and using this equation in particular, like z is going to be equal to x minus 16. So if x is negative 4, then z is going to be negative 20. Okay? And the way to plug all these in is to use the second one. This is negative 20. Okay? And then 3y, and then 7 times that is negative 28. Okay? And then 3y, y is equal to 65 over 13. Whoa. 3 times 65 over 13. Hold on. 65 times 2. Oh, 13 actually is a multiple of 65. That's what a mistake I made there, yeah. That's what I overlooked. 13 times 5 is 65. This is actually 5. Okay, that makes things a lot simpler. 3 times 5, this is just 15. Okay, that's equal to negative 33, so probably that's going to work out okay. That's going to be negative 48 plus 15, negative 33. That's correct. Okay, for some reason I couldn't see that. 65 over 13, I thought 13 did not go into 65. My mistake. Okay. Okay, let's see now. Yep, that brings us to 16. 5y plus y plus 3z is equal to 1. X minus what? It should be an x. X minus y plus 3z is equal to negative 7. And negative x plus y equals 1. So we're going to, we've already eliminated z, so we're going to take the first one, subtract the second. That's going to give us 4x. First one, subtract the second, plus 2y. The z's cancel. First, subtract the second. That's going to give us 8. And then we're going to just copy over the third one again. Negative x plus y equals 1. Now we have two equations with two unknowns. And we can find a way now to eliminate one of the other variables. Let's see, the easiest way probably is to multiply this one by 2. 2 and 2. And then subtract these two equations. 4x minus 2y is going to be 6x. Equal to 8 minus 2 or 6, so x equals 1. And just plugging back in here. If x is 1, y is going to have to equal 2. Because 2 minus 1 is 1. And then z. We can get z by going to, let's say, whichever of these looks the easiest. I would say let's just take this one. X minus y is negative 1. Put there as positive 1, that makes negative 6. 3 times z is negative 6, so z is negative 2. Okay, now we could substitute that in as a double check on the first equation to see if that comes out right. That's going to be a negative 6. It's going to be a 2. It's going to be a 5. We add all those up and we get 1. And indeed, that's 7 minus 6 equals 1. So that's number 16. And we're down to our last one. Number 18. 4x minus y plus 3z equals 10. X plus y minus z is equal to 5. 8x, excuse me, minus 2y plus 6z is equal to 10. Okay, now, okay. Interestingly enough, I do see that. Look at the first equation and the third equation. This one here, if you double all this, double 4 you get 8, double negative 1 you get negative 2, double 3 you get 6. So there's a problem here because if you had an x, y, and a z that satisfied this first equation to give 10, those very same numbers are going to give 20 down here. So you can't satisfy all these three equations at the same time. This you can kind of see it by dividing through by 2 on this one. If you simply divide both sides by 2, this becomes 5. This becomes 3. This becomes 1, and that becomes 4. Now this equation and this equation, the only thing that's different is on the right-hand side. So those are going to be 2 planes, but the planes are in the exact same shape or slope. In 2 dimensions, it's a slope. They're never going to intersect each other, because any solution on this can't possibly be a solution on that, because when you take 4x minus y plus 3z of any point that's on this plane, it's never going to also be on the other plane. Because the other plane, that very same combination produces 5. They have to be a different, see, these numbers have to be different in a way in order to get an intersection of the planes. So this one is inconsistent. And that makes it easy for the last problem because there's no solution. Well, so you can say it's the empty set. Just that there's no solution. And okay, that was longer than normal. Okay, but it's not the longest one I've had, but it's close to it.